Assalamualaikum and good afternoon. First of all, I would like to thank Dr. Muhammad Sa'ari bin Muhammad Isa and technologist Liana binti Roslan for attending my presentation. My name is Muhammad Yusuf Ishraf bin Muhammad Aziz. My metric number is B0818105393 and my supervisor is Dr. AKM Zakir Hussain. Today, I will be focusing on my project development. Last semester, I had decided to do a research about microstrip patch antenna. So this semester bring me to simulate some of antenna with different type of substrates and different radius of bending for polyimide substrates. I am going to brief overview for this project. This project consists of 5 chapters overall. First chapter will explain about the objective and scope for this project. Second chapter discuss about research and that has been made last semester. Third chapter show method that has been used for this project. Fourth chapter explain what the outcome and result for this project. And last chapter will conclude the whole project, which is successful or unsuccessful. Next, I will demonstrate how I get the output from the simulation. The software that I use to simulate the microstrip patch antenna is CST Studio Suite 2019. So, without any further information, let me share my screen to show the poster that I made to summarize the overall project. And after that, I will demonstrate using CST Studio Suite 2019. So, first of all, I will explain about the introduction. The project is focusing on the designation of the microstrip planar antenna to work on flexible substrate for the 5G application. The CST Studio Suite 2019 simulation software I used to simulate microstrip patch antenna. Next, for the problem statement, most microstrip planar antenna design could only provide a limited bandwidth. Second, microstrip antenna design are difficult to implement on broad bandwidth. Next, take a significant amount of time and money to establish the strategy and intended outcome. These are the problem statement for the previous research. Next objective for the project is to determine and simulate the microstrip patch antenna on PCB with wide bandwidth that can be used in 5G application. Next, to state and simulate the antenna on different flexible substrates. After that, to implement a prototype of microstrip patch antenna, which is the hardware fabrication. So basically, this is the flowchart for this project. First, we state the objective and problem statement. After that, we do a research on previous paper. After that, design the antenna using the software. After that, if the CST show success result, and we can continue. If not, we have to redesign the antenna in the software. After we get the successful result in the software simulation, so we can proceed to fabricate the antenna on the PCB board. After that, we test the antenna using the suitable tools or machine. So after that, if the antenna works, so we can proceed to apply in our live or use for this presentation. If not, we have to refabricate the antenna on the PCB and test the antenna. So for the methodology, the method that I use is first I analyze, second I use to simulate, and after that I fabricate. For the analyze, I'm using for 3 different substrates to analyze the S parameter, which is Captain HN, PET polyimide for the outcome. So after that, I analyze with previous research and previous paper. So next, I simulate with 4 different substrates in CST simulation, which is for polyimide, FR4 substrate and Roger 3003 substrate. After that, I simulate one type of substrate, which is polyimide with a different bending radius. After that, I decided to fabricate one of the antenna for polyimide substrate. So this is the result that I get from the simulation. This is the design dimension, which is polyimide substrate with some parameter that I used to calculate. After that, this is the result for the simulation CST Studio. This is the S parameter for polyimide FR4 Rogers 3003 and VSWR for polyimide FR4 and Rogers 3003. After that, I simulate with polyimide with different bending radius, which is 10 mm, 15 mm, 20 mm, and 25 mm. This is the fabricate antenna that I fabricate in the UTEM laboratory, which is the antenna is on my supervisor. So this is the output for the S parameter for the fabricated antenna. Overall, the result I get is quite same with the simulation. So for application, the antenna can use for mobile satellite communication in GPS system and missiles for army or military. For discussion, characteristic of proposed antenna using polyimide substrate, first and foremost, suggested antenna 3 distinct substrate, polyimide, FR4, Rogers 303 will be compared. So I compared for the 3 as parameter from the 3 different substrates. Characterization of microsave patch antenna as well as antenna bending of antenna. So I compared with the different substrate and different bending of radius. To the conclusion, the antenna has a frequency range of 2 to 8 GHz. The suggested antenna also shown that function well in terms of radiation pattern and resonant frequency when designed in polyimide, FR4 and Rogers 3003 materials. For the antenna developed on a polyimide substrate, the bending approach was used. The simulation result revealed a substrate with a high performance. I think that's all for the poster presentation. Next, I will show the simulation for the CST Studio Suite 2019. So first, I would like to show the comparison between 3 different substrates, which is polyimide, FR4 and Rogers 3003 S11. So for FR4, the S parameter is the resonant frequency is 3.288 gigahertz, and the return loss is negative 16.49446 dB. For polyimide, the resonant frequency is 5.62 GHz and the return loss is negative 30.426719. And then for Rogers 3003, the resonant frequency is 3.42 and the return loss is negative 30.69 969,837. So from this research, from the simulation, I get for polyimide is highest resonant frequency. So I used to bend the polyimide substrates which different bending radius, which is this is the comparison between the S parameter for bending radius. So first, for 10 mm bending radius, the resonant frequency is 5.29 GHz and the return loss is negative 52.363791. For 15 mm radius of bending is the resonant frequency is 5.213 and the return loss is negative 32.63813. And then for the 20 mm radius of bending, the resonant frequency is 5.213 and the return loss is negative 29.929658. And last, for the 25 mm of bending radius, the resonant frequency is 2.958 and the return loss is negative 26.10511017. So this is the VSWR for the bending radius. The comparison between the bending radius require not too many different, but can be bending for the polymer substrate. We get the higher resonant frequency and return loss. So this is dimension for polymer substrate. So this is the dimension for the polymer substrate with the non-bending radius. In this one is for the bending antenna of polymer substrate. I think with the last explanation for the bending of antenna, that would like to end my presentation. Once again, I would like to thank Dr. Muhammad Sari bin Maisa and technologist Eliana binti Roslan for attending my presentation. I think that's all from me. Thank you and have a nice day. Assalamualaikum warahmatullahi wabarakatuh.